are Group 102, and today we are excited to introduce our project MedWise Healthcare, a chatty medical AI partner designed to make healthcare decisions faster, safer, and more personalized. Our team developed an AI assistant that acts as your AI care companion, helping users understand their health status within just 1 minute. So, what exactly does MedWise do? It starts with a chat triage that assigns a risk level based on your symptoms and provides clear next step guidance. If the condition is critical, it triggers an emergency alert and automatically routes you to the nearest hospital. It can also generate structured medical records, summarize imaging reports, and even offer traditional Chinese medicine advice for a more holistic experience. How does it work? The system begins with a chat interface that passes through a safety gateway. Then, the orchestrator connects our large language model to the triage and the risk engine, which interprets symptoms and applies clinical rules. It performs guideline lookups, triggers provider routing and notifications, and finally writes back securely to EHR or file systems with a complete audit trail. Finally, why do we trust MedWise? It's privacy first. It's the post-role-based access for patients, clinicians, and admins, and the resilient gateway. Thanks to its modular SOA architecture, every component can be extended, replaced, or scaled independently. To end with a quick story. The user says, I feel chest tightness. MedWise flags it as high risk, sends an emergency alert, generates a structured record for the doctor, and schedules follow-up reminders automatically.
This diagram shows the hierarchical structure of our health card system. At the top level, the system includes modules such as user and road management, multiple rounds of consultations, medical record management, triage and risk assessment, health log and reminders, emergency response, personality TCM advice, and medical route recommendations. Each module is further divided into specific operations, shielding the system's module and scalable design. Next. Look at this UML, these 3 main users, the system administrator, patient, and doctor, and how they interact with the health system. The highlights function like multiple rows of consultations. It will give medical record, TCM suggestion. The triage and the risk assessment connects to medical route recommendations and the TCM suggestion, reflecting an intelligent and integrated workflow powered by the LM.
This diagram shows the architecture of MedWise, designed using Cushion's 4+1 view model. It's built in 5 layers: clients, views, controllers, services, and infrastructure to keep the system modular and easy to maintain. Role-based interfaces link to controllers that manage chat, triage, and EHR functions, while backend services handle risk assessment, imaging, reminders, and routing.
This class diagram shows the overall structure of our intelligent medical platform. It starts with a consent access, which defines users, doctors, and patients, together with authentication subsystem that manage roles and permissions. Then we have the consultation context, which stores multi-turn conversation between doctors and patients. Each conversation is made of many messages, forming the basis for data record generation. The next layer is orchestration and AI services. The EMR service coordinates the LLM agent, template engine, and guideline service to automatically generate structured medical records after a consultation. On the side, we have data fusion and triage, where wearable data and the symptom reports go through the triage service to access patient risk. The platform also includes modules for routing and emergency handling, health logs and follow-up, and the traditional Chinese medicine personalization, as well as backend components for safety, privacy, and performance monitoring. Overall, this diagram highlights how all these modules are connected under a field governance framework, keeping data consistent, secure, and auditable across the entire system. Next.
Okay, the system-level object diagram shows the runtime instance of the main functional models of the intelligent medical assistant and their interactions. The scenario shows in figure is the system snapshot when user invoke the medical path recommendation function. Here, the patient analysis talk with the health agent. The agent use service like LLM, map, and TCM engine to find help nearby. We can see example result, hospital, clients, and the families. Each object has small details like name, distance, and waiting time. Connect for the collaboration. This diagram shows the part work together. The patient talks to the health agent, which checks login and consent. Then backend calls different service, risk check, TCM advice, emergency, and guidelines search. All results are sent back to the patient. The arrow like S1 or G1 shows message below between these models. Okay, next for the structure class, this picture shows the main structure of our health assistant system. The port on the side connect to the system with the user and other APIs. Inside, the control layer like UI handler and the section controller handles input and dialog. The service layers does the real work, checking risk, giving TCM advice, finding hospital, or sending emergency alerts. Data is saved in the database, and the result presenter shows the final result to the user.
Then looking at the package diagram, this shows how our system is organized into different functional blocks. We divided the system into key modules like the user interface, risk evaluation, pathway planning, and result presentation. Each of these packages has clean responsibilities. For example, the UI handles patient input, the risk evaluator assesses the urgency, the location manager processes geographic data, and the pathway planner connects external APIs to suggest hospitals or roads. This modular structure makes our system easier to extend, maintain, and test, so we can add new healthcare services without affecting existing ones. Next, in the deployment diagram, we show how the system actually runs in real-world infrastructure. From the user's browser, request goes through a CDN to our web server, then into the gateway. Behind it, services like Trigo, Rules, LLM, emergency notification, and also all run in Kubernetes cluster. We use PostgreSQL and object storage for data and connect to external services such as Maps, SMS, and LLM API through secure HTTPS and gRPC channels. This system also supports high availability, auto-scaling, and full auditing monitoring, ensuring both reliability and data security. Overall, our presentation shows how MedWise integrates AI tracks, risk assessment, and personalized care into some secure and scalable system. Thank you for listening.